ball is thrown off the top of a cliff with initial velocity of 4 meters per second upwards and a horizontal velocity of 6 meters per second. Neglect air resistance. Vertically, the ball experiences an acceleration due to gravity, and this is true of all of our projectile motion problems. Horizontally, the ball is moving at a constant velocity. Again, that's going to be true for all of our projectile motion problems. The only time the acceleration due to gravity would be anything other than, say, 9.8 would be if we put it on another planet. What is the position of the ball after 3 seconds? So I need the x and y location of the ball after 3 seconds. Alright, so if I look at my hint, the hint is basically that, remembering that our rule from before, every time you have an acceleration, you have a list of givens. So here I have two different accelerations. I have the acceleration due to gravity and the fact that the ball is moving at a constant velocity horizontally. So constant velocity means the acceleration is equal to 0. That means I'm going to need two lists of givens. One with everything that's going in the direction of up and down, and the other one with everything in the direction that's going left and right. So now let's look at the givens. If I look at the givens, I'll slide this up a little bit. So I can see that vertically it's going up at 4 meters per second. The time is at 3 seconds, and 3 seconds goes in both columns because time is a scalar. So once you find it for one value, it automatically goes in both. And the acceleration due to gravity is going downwards, so that's going to make it a negative 9.8 when we put it in our formulas. Horizontally, the acceleration is equal to 0 because it says constant velocity, and horizontally, we know the velocity is 6 meters per second. Now with these, I can use my vertical givens to find the vertical position, and then use the horizontal givens to find the horizontal position. Remember, when doing this, don't borrow variables from a different column. Just like we did with kinematics and previous problems, stay in the column when you're solving the problems. So when I solve this, this becomes the answer. Using only the vertical givens, I can find out its position. So vertically, I know the initial velocity is going to be 4 meters per second, t and a. So I need an equation with v naught, x, t, and a, and that's in this case, the x equals x naught plus v naught t plus 1 f a t squared. I put in some y values just to reiterate that it's going up and down, and I get a negative value. So the negative means it's below the starting height, because 0 is always going to be our starting height. And horizontally, I use the same equation, x equals x naught plus v naught t plus 1 f a t squared. And horizontally, this always boils down to x is equal to v naught in the x direction times t, because horizontally the acceleration is always going to be 0. It's always going to leave us with this equation. So horizontally it's going to be 18 meters. What that means is that from the initial position, which we're calling 0, which is up here, after 3 seconds, it's going to be negative 31.1 meters from the starting height, which means it's downwards, negative meaning below the starting height. And the x direction is going to be 18 meters, and so that, right there where the dot is, that's where it is after 3 seconds.